So what are these iterables, iterators, so generators and coroutines? You have already seen about what are those iterables. Iterables means any object which supports for loop on it is called as an iterable. That we already saw. But if I want to go in detail, so one such thing is about the basic iterables that we have seen. It would be like a refresher for you. But what I want to mention here is about in iterables, what are the different kinds of iterables that we have seen? So starting from say the built-in objects, we have applied for loop on everything. In the basic data types onwards, if you see, so we have worked on like different kinds of loops. We have seen that when you apply the for loop on a ordinary numbers, we cannot do. But if you do the same thing like a string, it will work because strings are iterable. So strings, we can iterate directly. Each character at a time we can come. So if you have a list, if you have a list of values also we can iterate. We have a tuple of values that also we can iterate. We have a set of values we can iterate. But the problem is we don't get the order them in a proper way. And coming to the dictionaries, when you are iterating, I told by default, when you are iterating over a dictionary, you will get only the keys. If you are explicitly want the keys, you can specify dot keys or explicitly values correspondingly or explicitly dot items. Similarly, if you when you are retrieving the values, not every time you will get one value at a time. Especially when you go for the pairs, you will get two values. Then you can do like a tuple unpacking by assigning to two values. On top, if you are doing an enumerate, this is very interesting. When you do enumerate dot items, you will get three items because you will get the loop index and the key and the value. So when you are getting like three values, you cannot do directly like this. This is one of the interesting point. You see the loop index and you are getting a tuple of two values. Observe the syntax between these two lines, you will understand. Whenever you are having an enumerate on the dictionary items, we should use in this way. So these braces makes a lot of difference in terms of tuple unpacking also. Lastly, so when you have like multiple values coming, if you go for like a typical list, in this list I have 4 values in a pair. So each time when I loop, I'll get 4 values. So I can assign to 4 correspondingly. And did you observe carefully here? I did like a asymmetric unpacking. I told in Python 3.6 onwards, I guess, this feature came. In Python 2, this feature is not there. Asymmetric unpacking means if you don't give exactly the whatever number of things, it will throw in error. But if you are not sure how many values you're gonna get, say if you are interested in the first two or like first and last like that, whatever the remaining, so you can place like this. Then remaining will go to like a tuple. So that is like a asymmetric unpacking. So next, within these things, you will learn about the enumerate. We have already seen about the enumerate functionalities, just like a revision. Enumerate means what? You will get the loop index of whichever the loop you are working. Typically, when you go for a typical for loop, instead of you initializing a value and incrementing and getting the loop count, you have enumerate built-in function. At the same time, I told that along with your function, so you give any iterable, generally for looping, and apart from that, you can give a starting, means like some kind of offset you can give. If the offset will be added to it, if you don't give, it is like a 0. But the offset should not be like a floating point value. So it should be integer only. This is one more point you need to understand. Okay, these two I understood, sir. What is the next thing? When you are working with the iterables, let me introduce you to two new built-in functions called as all and any. So you might have learned about till now the basic data types about the bull function also. You remember in the bull function, I told that if you give like an integer or a float, so if the value is like a 0, then you get false. Non-zero, you get true. If it is a string, if it is empty string, you get false. Non-empty string, it's a true. If it is a braces, empty braces, it's a false. If it has at least one element, it's a true. So this is what we learned, right? But till now, we didn't work on the iterables at that time. The same boolean, if you are applying on iterables, it will apply for loop with the bool function on each of the element and give the final result. By the name it says, all will be true if all the elements are boolean true. Any will be true if at least one of them is true. Observe carefully. So they work on top of the boolean values because iterables are working on top of basic data types, right? In the same fashion, this also works like that. So in terms of working, if I see, you can understand that. You see here. Generally, you remember, I'm just giving a revision. Boolean of 1 means true. Boolean of 0 means false because they were 0 and non-zero values. Similarly, for floating point, I told floating point value, negative floating point value, also it will be true. If it is absolute 0, then it is a false. You have a string, at least one character, even white space is also one character, then it is true. If we don't have even that, like an empty string, then it is false. So with these things, if you go on a for loop and do for each of the elements, if you observe carefully, I am doing a for loop and I am checking the condition. If not boolean of I means what? I am expecting a false. Generally, not boolean means what? So boolean you expect means you expect true. But if I say not boolean, I am expecting the bool should result a false. Means if at least one of them is false, it will go to this condition and it will break it. So observe carefully, I wrote an else. You remember I told that not only for if conditions, for loop also we can have an else. This is very, very careful you need to be. So in other languages, you don't have it. So Python, it is one odd special case. I never seen in any other language. But what is the for loop concept means that in a for loop, if there is an else, if for loop is designed to execute for n number of times, if the list is having these many elements, those many times this for loop should execute, right? But if in any case it didn't execute one of them at least, then it will not go to the else. If it executes all of the things, then only it will go to the else. This is the uniqueness of else for the loops. Same for while loop also you can have an else condition. Same logic works. Sir, why does a for loop will not execute everything that was given means there is a break or a continue, pass. So pass will not make any sense, of course. Break and continue will make sense. Whenever this break is encountered, the remaining loops will not execute, right? So in that case, it doesn't work. Now take an assignment. Instead of break, place a continue. See whether it is going to the else. Okay, coming back to this scenario. What I'm trying to say here, you are going to each of the element and trying to get the boolean of it. As everything is an integer, so you expect it to be, so if you want a boolean true, it should be so non-zero. If you are expecting not boolean means what? It should you're expecting a non-zero. So you are expecting a zero value. If it tell there is any zero value, it will break the code and it says result is false. Instead of you implementing this much logic, so you can simply write this all built-in function which will do the same thing. Go to each of the value, check the boolean whether it is boolean values zeros or not. Observe carefully, there is 1 0. So the result will be false. If everything is non-zero, then it will be true. All. That is the beauty of all function. Similarly, going to the any. At least one of them is true, then it will be good. So if one of them is true, that's it. It will break. It won't even go to the next one. If everything is breaking, then it do. So instead of you writing this much manual logic, we wrote like the any of the function. Now, if you apply on a larger scale, so you can see that. So in which cases I use in real time? Say I create some kind of ETL pipelines. During the pipelines, I have like every job doing some statuses. So ultimately, I check the end status. If every job is then done perfectly, so a result will be true for me. So then I can do the next job. So like that, you have your own logic how to implement. But so this will work like this. You see, all will be false because at least one of them is zero. Any will be true because at least one is true. If you even none is a Boolean false, right? So if you have a string and like all of string, if you see you have a single string, but like it will go to each of the character and do. Of course, if you have a string, it's fine. Even if you have white space also, it's a fine. In fact, this is one of the interview question actually. So that's why I gave. And one thing you need to remember, Boolean of empty string, one space is also true, but empty string is like a false. That's a difference. So today you learned one more built-in function within those 69 built-in functions. So next for us is on to the sorting. We have already walked through the sorting just to refresh you. So yeah, this is one of the questions that you need to ask. What is the sorting algorithm used in Python? Generally for sorting, there were different algorithms. If you don't know, so we can see when you are going to the algorithm class. But typically, sorting can be done in different ways. One of those methods is called as a tim sort. Tim sort is a way that we are using built-in. Every language will have its own sorting algorithm. To the best of my knowledge, even C++ and Java also using some kind of tim sort only. So tim sort, so is like sorting. And also, reversed is not about reversing in a reverse order only, not in ascending or descending. What are the order if the values are there? It will just do a mirror flip. That's it. So you know about the sorted built-in function and sort attribute. So sorted built-in function will create a new object. It will do sorting in an ascending order by default. And if you do like a sort attribute, it will make the changes to the original object. That also we have seen. And by default, it will do sorting in an ascending order. If you explicitly want in reverse direction, we should say reverse equal to true. The same thing goes even for the sort attribute. But sort attribute we cannot apply for all data types. Only for list we can apply. If you go for other iterables, only sorted built-in function is the only way. And reversed, as I told you, it will just do like a mirror flip of the original values. That's it. And by default, reversed will give a list reverse iterator. So this is the first time I told, right? Iterator. Next we will see. So this is all about different examples where you want to do like a custom sorting using those values. So hope we have done like a good amount of explanation. Now the point. So why we go for like these iterables I told. Next, coming to the case of iterators. What is this iterators? When you have like small values, you have individual data types. To store those individual data types, you need a data structure. That's how iterables came to picture. Now, what is the concept of having these values? Iterators. Iterators means to optimize these iterable objects. Means why you need iterators. Simple logic. When you have too many values, just imagine, I will give a very simple example for you to understand. If you have, so one integer, it is occupying two bytes of memory. So you can store that much, it is easy. So tomorrow in a list, is there any practical limit of how many values you can have in a list? No. Assume that each one is 2 bytes, right? If you have like, 20,000 values in a list, then what will happen? You cannot store that much. Then obviously your list will crash. List means your Python process will crash. Means whatever the job which is running, which will fail. So you don't want to go to that scenario because only in Python, there is no limit on the memory. In other languages, we have a limit on memory. Means does Python is a super language? No. It will convert whatever the code you give into the backend C language or like Java like that. So mostly 80% or 85% we work on C-based implementation. So it will take care of that memory management in the backend. But so the point is like we should have a limit on how much data we are processing with the iterable objects. Else your thing will crash. To avoid that, the first thing that we have discussed is about uh, range. If you go to the range, range is the first function you have seen which is working like a optimized object. Hope you remember when we working with range, I told that if you go into the interactive mode and ask, hey, give me the range of values. So it will not give the values for you. It will say that this is the state. I need to give the values from 0 through 9 with a step of 1. So in Python 2, it will give all the values. That's why Python used to crash. So what is this actually doing, sir? Means like initially it will store the state that I need to give the values from 0 through 9 with a step of 1. So each time you go and ask, hey, give me one value, then it will change the state that, okay, I gave one value, right? Now I need to give the values from 1 to 9. So next 2 to 9, 3 to 9, like that it will go till the last. And finally, so it will be done. So this is a better way, right? In this way, if we generate 1 crore values also, it will make no much difference. In a way, I would say it is a on-demand computation. So this is the correct word to use. So for this list range, I told that it's an optimized object. And the most important thing is called as lazy loading. Means lazy loading means, as I told, until unless you need it, it will not load it. Or on-demand computation, the same word in a different way. If you want the values, either you for loop on it, where each time you explicitly go and ask for the values, or you use like other iterables, means convert to a list or a tuple or a set or even a string. So when you're converting to string, it will not iterate, just convert. That's why it will come as it is. So this is one kind of optimized object you have seen till now. If you remember, we have already worked on similar kinds of optimized objects. If you see here, so we worked on zip, map, filter. So what is the zip and a map and a filter that we have seen? Let me show you. You remember when we have seen, this is all kind of a revision of what you have learned. That's the reason I'm making fast. If you have two iterables, it doesn't mean that both should be list or a tuple or anything, because it will loop generally. So zip, what it does, if you give two iterables, it will go to the corresponding elements in each of them and it will try to pair. So if there were asymmetricity in the values length, it will go to the minimum length as much possible. So fine. In the same fashion, if you see here, zip, the result of a zip is an optimized object. In Python 2, it is a typical list. They found that this is a problem. In Python 3, they handled it. So what it is actually doing, same like in a range, if you want the values, either you can do a for loop or you can convert to any of the basic data types. This is what we have learned, right? So this is the second optimized object that you have learned. So the next, what if you want to create these kind of iterable objects? Means like, so one interesting point I will tell you. What is the difference between range and these objects? And the next custom object that I am creating. Let's deal with the custom iterators or user-defined iterators. If you want to create an iterator, so there were certain rules. What is an iterator, how it works, and others. And to create an iterator, we have a built-in function called as iter function. This is also called as iter protocol because it has set of rules called as protocol. So generally, other built-in functions are called as general functions. So, but now it is called as iter protocol. So iterator is like an immutable. So immutable, observe this point, disposable and lazy loading. So means like initially you have a list. So list is having some type, values and a length. This is what you know till now, right? If you have a typical exit. So if I navigate to this 09, 02, clear and Python C so and so. Did you observe it's a typical list? It is having some length. Fine. Now for this list, we generally know we can do indexing, slicing, and all these things, right? From a typical list. So if I execute also, you'll get the corresponding values. Now I want to create an iterator from it. How do you create an iterator means? You need to use the iter built-in function. Just pass your list or a tuple or any iterable to it. It will create an iterator. Just it will create an iterator. Then what is the point of this iterator, sir? After creating an iterator, if you ask for any of these options, like if you ask the length, it will throw an error. So you cannot do indexing. No, you cannot do slicing. You cannot do operations. Means it is an ordinary list till then. Once it becomes an iterator, you cannot get individual values. The only point is you can get one value at a time. That's it. So when you have large data, they used to manage like this, such that memory will not be that much affected. Now, sir, how to get the values? We can do like a for loop and get the values. If I do like a for loop, I got all the values, right? Whatsoever are there. Fine. What is the other way of doing? We can convert to an iterables. I did like the converted to an iterable. So this time I should get a list, right? But you won't get it. Did you see when you convert to list, I don't get it. Sir, why? What is the problem? The problem is that this is a disposable object. Disposable means once you get a values, you cannot get it again. This is the first time you are seeing this kind of scenario. Even in map, filter, zip also the same logic works. But I think you didn't practice much. But you can try that as an assignment. So once you get the values, if you ask again in any other way, you cannot get. So then how to get again? Means you need to redefine again. If I define and again ask, you observe carefully, I created an iterator, then I converted again to a list just for my visualization. So now it is working. Similarly, you create an iterator and convert to a tuple. So you get like the tuple. See, I created a tuple iterator, iterator and converted. So like that, I can, every time if I want the value, I need to do like this. So that is the reason range is not called as a pure iterator object. Because for range, any amount of times you go and ask, it will give the values. It is not like a perfect iterator. So disposable object. So these were all the disposable objects. So there is no much magic in iterators. If you want to create, you pass on to the iter built-in function. That's it. You can create an iterator. So next, going further, one thing I want to touch base is like, you create an iterator, right? From a list, if you create, it is called as a list iterator. Observe, this name is also makes very sense. Whenever you are creating an iterator, you will have a base iterable object, right? If you are creating from a list, it is called as a list iterator. If you are creating it from a tuple, it is called as a tuple iterator. If you are creating from a set, it is called a set iterator. Even within dictionaries also, if you create from a dictionary, by default, it is called as a dictionary key iterator. If you don't give explicitly or explicitly also. If you give like a dot values, it gets dictionary value iterator. If you give items, dictionary items iterators. If you give string iterator. Sir, why string should need to be optimized? Will string become big? Yes, of course. Sometimes if you are reading one page of data, so one log file very big enough, then it also can crash the things. So each character can occupy 1 byte. So if you see overall, how much it will take. So that's a point we need to see. So this is all about the iterators. So similarly, till now we are doing about the loops. What is the other way of doing the things? If you see, you can go and ask one value at a time. So generally, when you have values, you loop over each. Till now, you didn't face the issue of trying to get an exceptions and others. But observe carefully, either iterate over it using the for loop or using these built-in functions. And also we can use another new built-in function called as next. So this is another built-in function you are learning. What is the point of this next? Generally, till now, this is way of looping, right? But using underscore and underscore next attribute or next built-in function. So either of them you can use. Most of the people feel comfortable with next built-in function. If you generally ask, it will give the values. And observe here in this case, there were 3 values. For the first time, if you are asking, it will give 1 value. Second time when you are asking, it will give second. So first time what it will give? So foo. Second time when you are asking, it will give like bar. Third time when you are asking, it will give buzz. So it don't have further values. If you further ask, it will throw an error called a stop iteration exception. For the first time, you will see this. So when you are asking beyond, so the values it has, it will do like this. But sir, why it didn't throw an error when you're doing for loop? For loop is intelligent. It will ask only till the values it has. It knows once you give a data type, it will understand how many data it has and it will ask till that only. Whereas if you are doing like this, individual values, it will do. So if you need to parse these iterators using a while loop, this is how I parse. Each time I try to get, anyhow, at last it will break. When it is breaking, I do like, try exception and break the code. So hope it's fine. So like this. This is how we work with user-defined functions. So just to give you an explanation, I told about the iterators and others. So one last point I want to mention here about this better data management strategies. So when they found like, Python 2 is crashing very often, they decided to this architecture because for better optimal usage of memory. For non-iterables, they are very small. There is nothing to do. These iterables only we store, those non-iterables only we store in iterable objects. These to optimize only we have iterators. But similarly, what if you want to optimize the logic, means custom logic, means you use the different functions. So that's where we have something called as iterators, generators, sorry. So that is another thing. So just to mention. But before that, I just want to touch base on something. There are other things called as iter tools basically. So you need to be aware of this other thing called as iter tools. So iter tools. So IPython notebook I am trying to create. Sure, it works. Seems there is an issue. Actually, I need to handle it afterwards. Okay. Iter tools example .py. If you see in this case, okay. So what is an iter tools? Why we need to use it? Iter tools is a built-in function. So if I do like a dir of this iter tools, CLS and Python iter tools. Basically, what is this concept of iter tools? Why we need it? If you see carefully, whenever we have this kind of optimal objects like iterators, generally, if you have 2 lists, we can add it, right? If you have 2 tuples, we can add it. What if you have like multiple things? Let's take a simple example. I have 2 lists. I can add values. Python. If I go, if I have 2 lists, say list 1 is equal to some values. So all 34, fine. List 2 is equal to say 45, 67, something. If I say L1 plus L2, this is list concatenation. What if I have list 1 iter I created, which is like a iter built-in function of list 1. So list 2 iter, which is like a iterator created from list 2. Now if I say list 1 dot iter plus list 2 dot iter, What is saying? Hey, you cannot add to list iterators. Okay, sir, I cannot add. What if I try to add to that iterator another value called as like this? Means you cannot do a direct operations on these things. To work on these things only, we have this iterator built-in function. So what are all the things we can do with this one? If you see clearly, say if I say import iter tools, if I ask the help of these iter tools, you can notice what kind of things we can do. We can create a count of values. We can continuously give a stream of values. And we can repeat the same values again and again, or cycle, chain. So chain means like combining. So there are multiple such things. So to touch base on this first, on these iter tools, if you see, so first thing is like the itertools.accumulate. So itertools.accumulate. What it does actually does is like whenever you want to do like cumulative sum. Have you ever heard the concept of cumulative sum? Cumulative sum means, let's say you have a range of values. If I go and ask range of values from 0 to 10 with a step of 1, so you get these many values. For all these values, if you want to get the summation, then what you do? Sum of range of 10. If you do like this, you will get the total sum. But sir, what if I want to get the cumulative sum? Cumulative sum means what? Means for that position, what is the total values? Let's say initially I started 0, it is 0. First position 0 and 1. For second position 0, 1, 2. For next position 0, 1, 2, 3. So like that it will do add all the values. So that you can see you will get as much number of values as the original input. But till that input, what are is the total sum? Did you see the final value is same as the total sum? This is called as itertools.accumulate. So similarly, when you are doing accumulate, we can pass like some kind of operators also. Means generally, so okay. So there is one more module called as operators. Operator is like very much useful for predefined actions. Till now, you know, accumulate will do the addition, right? Cumulative sum. So it will optionally take one operator. For that, we need to pass operator.add. Someone asked me, sir, can I use a plus operator? No. You can write like a custom function or you can use this operator, either way. You see, this is how it is working. But for the same thing, if I go like instead of a operator.add, if I do operator.multiply, it will give a cumulative multiplication value. Sir, why all zeros? You know, for addition, if you add a 0 to everything, it makes no difference. But for multiplication, if you multiply with 1 0, everything is done. So if you want to understand, so range generally, if you don't give any value, it will start from 0. But if I give explicitly some value, saying that, hey, start from 1, it will start from that 1. You can see that from first position onwards, it is going on. So 1 and it is multiplying with 1 and 2. 2, 1, 2 means 2 and 3. So like that, it is multiplying with all the values. This is another thing about this one. Next, we will see about something else called as permutations. Permutations means from a single thing, how many types we can create. So generally, if you ask like itertools dot permissions, you don't get the values. For us, itertools means everything is like an iterator. For us to understand, we convert to list. So it's easy. If you have a single value, how many permutations it has? Only one. If you have like two values, it can have two types, right? So you can have. Similarly, if I have like a three values, A, B, B, then you see 3 threes are 9, 9 times. So it will return successively n or length permutations of elements. Similarly, if I do for the same permutation, if I say r equal to 1, means until now I'm not giving any option. It will give how much generated. But if I give anything, it will generate only till that. Means what I'm telling to say, I have one value, I'm asking give only one. So result. If I say I have two values, generally when I have two values, what happened? You got like two pairs, right? But in each pair, if I say only one value should come. Now, did you understand? Though you have values, it will not use it. Now, for the same thing, if I ask, hey, make two values only, now you will get two values. Similarly, if I have three values, and if I say r equal to none, if you don't give r, it is by default none. When it is none, how many possible combinations it can make? Those many permutations it will do. So 3 means it got like these many times. Similarly, if I have the same 3, so if I say explicitly 3 also, as it has 3, it is done. Okay, sir, it has 3, it is doing. What if I give like, 30? Will it do? No. So it don't have. But generally, if it has like some values, it should generally generate that much, right? But it doesn't work like that. So how much you are giving, it will work till that much only. Hope it's clear. So next, similar to this itertools dot permutations, there is another thing called as combinations. How does the combinations work? So same like this one, but with a slight difference. Most of the people get confused between permutations and combinations. Permutations, you have seen how it work. But combinations, you see, if I give 1 and this r equal to 2, you got like empty. So means combination means combining. Think like that. That is the best way to understand. If you have two values, when combining, only one set it can combine. So in R, you are telling that I want a pair of two values. So if I give 3 also, I want pairs of two values, you are saying. How many such combinations it can make, it is giving. So permutation is called a selection, and this is combination. And if it has 3 values, and if it has pair of 3 values, with 3, how many pairs it can do? Only one pair. So, but if I say A, B, C, D, again B is there. Means I have one of the character in the input itself duplicate. Then it can generate, you ask two value pairs, it is generating like this. Similarly, if I have some big number of values, if I say uniquely, the pair should have only one value. Then you got like that. But if I say pair should be 0, you get nothing further. And similarly, so if you want to, so 3 create like, this is one of the use case. So just to give one example, if you are given a one word, and if you want to create like a 3-word pairs, you see in this case, what will happen? You are going like AEIOU with those things. I want a three character pair you want. So each time it will generate those many values. And each one is like a pair of 3 values. And you are using a delimiter inside to combine them. So did you see using vowels, you got these many combinations? So like that we can do. But one thing is like this combinations is like a unique value. Did you see anytime the same thing repeating? Means A, B and BA are both same, right? Literally. That's why it won't give a repetition. But if I go for like combination with replacement, then things will change. So how it actually works means, if I go here, combinations means nothing. So with replacement, if I ask the same, so in the same fashion, I told about the combination with replacements. So the next thing is about the compress. So if you see about the compress, by the name it's saying it is trying to compress. Compress works similar to zip but not zip. Zip means what? It will pair two iterables and create a pair, right? Whereas compress means you give one iterable and you give another thing like another iterable or anything. The second values, Boolean value it will take. Means in reality, you will not pass like true false. You can pass like 0, 1 or like something else you will pass. It will take the Booleanness of each of the value and corresponding value will come. See here, so you have how many variables? Those many Boolean values are there. First one is Boolean true. That's the reason you will get the A. Next is a false. That's why you don't get B. See, B is not there in the output. Next you have false. That's why you don't get C. Next you have a true. That's why you get D. Next you have like a true. That's why you get E. Next you have like F, which is false, you don't get it. So lightweight corresponding values, it will go and get the values. Means it's not just doing on the basic operations. We do much more things with this. So next, if you see in this example also same thing, wherever like boolean 0 is there, so it is not coming. In other case, it is coming, right? And it's a very simple example. 0, 0 you placed. So did you see you got 0, 0? You may ask me a question, sir, it is 0, 0, but why I got A and P? Because 0, 0 as a list or a tuple is different from 0, 0 as a string. In a string, empty character is different. Character having at least one character is different. It is 0 as a character. 0 as a character is boolean true. So that's why first two characters you will get it. Whereas here if you see, first two are zeros, remaining you didn't even give. So nothing you'll get. Hope you understood. And the next thing is about the group by. Hope you are comfortable with the SQL based group by. But this is another group by. What is this group by doing? For to explain to you, I took the string module. You remember in string module we have ASCII lower, means you'll get all lower cases. Just to have like some values, I took that. So instead of that, I also can use some kind of text just to show you. There is another built-in function called as random, so which you will learn afterwards. This is a module. So random dot choice of value and k equal to 20 means it will give randomly some 20 characters among them. And did you see that the same character will not come again? It will give randomly some characters for us. That is okay. Now, within this, if you do a sorting, you get the sorted values. Why I'm telling all these things? Just to tell you that if you have any list, if you want to first group by, you need to sort them. This is the most important point you need to learn. In a SQL, if you want to group them, just you write like the group by a particular column. But in Iteratools, if you want to group by, first, if you have some list of values, you need to sort them. If you don't sort, then it will have the duplicates groups. So if you sort them, then it will be very good. To use group by, first the elements need to be sorted. That's the most important point you need to learn. Then after doing, if you do a group by, now we see here, how many times B is occurring, how many times C is occurring, like that you have, right? And did you see that Y is occurring 3 times? So U is occurring like 2 times. So like that you have. Now did you see when you're grouping, each of the key you will get, what is the group it will get? So if you see, if I'm printing, for each key, what is the group of values you got? Similarly, if I have a data, which is like a list of tuples. So the list is like a number and like you have a string. So number and a string, number and a string. When you did a group by, did you see what you got? And notice, you can understand one problem here. If you observe, here I didn't make any kind of sorting. And if you see, the same value is coming twice. If you see here, so this is good. And if this is case, this is fine. And did you see, for the same ABCD, you got one group. And similarly, the same number, you got like into another group, right? So this is because they were not sorted. That's the reason, if I sort the data, so sorting based upon which are the value. Say I'm sorting by, so the first value. So then if you see, they'll be in a sorted order in the group also. When you give, perfect grouping will come. Means it doesn't mean any group if you create, first we need to sort them. Then similarly, so yeah, this is a custom grouper. I am writing a function to check whether it is even or not. Now for this, first I am doing a sorting by what? See here, by check even. If it is even, so first it will, all even values will come first, then the odd values will come next. This is one kind of custom sorting. Then when I'm doing group by also, I pass the same key on which parameter I'm doing sorting. Generally sorting will happen by value, right? That's the reason till now you didn't pass. But if you are doing any custom sorting, you should do custom grouping also. So you will get like that. This is also about the concept of grouping. Next, coming to the counts. Infinite counts you can do. Means what? If you give like a 10 in count of 10, then what happens? You can do like a while loop. In a while loop when you are working, so from the starting when you're looping from 0 till that value, it will go to continuously and it will give. So generally from iterators, if you want a value, you need to do next, or you can do for loop. For loop means you can do only for a finite number of times, right? Or like you can give a range and you can loop for that much times. Here also I took like only 30 times. But if I do the same thing for 100 times or 1000 times or 1 crore times, doesn't matter. It will give the values. And did you see that it is giving a continuous sequence of values? So without any difference. But if you go on asking, it will give. So it will give that kind of infinite count of sequences. But sir, why it is taking this 10 first of all? Means to generate the values from 10 onwards. Means what is the starting number? From there it will give. And it will take only the integers. Don't give floats. If you give a try, you can try. And if I give, see here, if I give 3, from 3 onwards it is generating, right? Similarly, if I give 3 and the second value is 2. So the initial value and the step. Because there is no concept of final value, right? Generally in range you have a final value. Here there is no final value. Here initial value and the step. So every second value you are getting. Similarly, initial value and the step I give. From 3, every fifth value you are getting. Similarly, if you want to count down, so from 3, if you do -1, every time it is subtracting one value. So you are getting to the negative values. Next, if you go to the islice, hope you remember I told that there is a slice built-in function in Python, but we don't generally use the slice built-in function I told. If you want help in IPython, you can do a question mark. You will get it. I told that whenever you are working on any list or a tuple or a string, anytime when you're doing a slicing, the slice built-in function will execute in the backend. Generally for a list, if you have a list, you give my list, you get the values like this, right? So starting value, final value, and what is the step. But it will, when you give these values in the backend, it will use this only. In the same fashion, for ordinary list, we have this slice function. For these iterables, we have islice. Same thing. You give a values, you give something, you get that much things. So you can give like one value, two values like that, right? So slice, which will give. If I give 5, it is getting the 5 values. Similarly, for the count, if I pass this one, count I told, right? Count means what? It will take the starting value and it will take the step. From 10, it should do like a step continuously. How many times it will give? If you want like 15 values, you can give. Instead of you looping, you can do like this, such that in runtime it will generate these values. So, sir, why can't you generate this count and loop our for loop for 15 times on your own? Instead of we doing all those things, it will do for us. Similarly, if you see, I slice of count of 10, 15 and 15, if you see, and convert to a list, you got the same values. So this is all about the count. And also this I slice, not only so how many values, start, final, and like, so step also you can give. So same like slicing. So one value if you give, it will go till that much. So if you give 2 values, starting and end, if you give 3 values, starting, end, and step. So like that you get. Similarly, iterators.cycle. Cycle means like it's very simple. Count means you got a continuous increment of values, right? Or decrement. Cycle means the same values will repeat every time. So basically, I created a for loop that you loop over it. If I don't write this condition, then it will loop for infinite amount of times. That's the range. I created this condition to do loop and break at 7. So cycle also can create infinite sequences. If you see from 0 till 7, I am asking each time value. So in these values, each time it will give 1. So first one is like head. Next time you are asking head, tail. Next time head, next time tail. Like cyclically, it will give each value. So if you see itertools.cycle of this thing, if I loop again, I get it. So if I say itertool.cycle and I pass down I slice, because I want 10 values, if I pass, I get 10 values. Means if you have some list of values, you want to repeat each of them within that in a continuous fashion. But if you want the same thing every time, you can go for repeat. In repeat also, it will take the iterable, but it will repeat the same time how many times you ask. So that is the difference. If I say itertools.repeat of 4, if I give. So the beauty is like repeat is not an infinite. So by default, it would be infinite. If you give some number, it is a finite thing. It will generate the same thing that much times. And the next thing is about the chain. So this is the reason I started and I evolved all the way. So if you have some iterators, you cannot do basic operations. And also I told, when you create an iterator from some base object, it will get that name also correspondingly. So as I told, if I do add two lists or like two iterators, you cannot do. So if you add the same iterator to iterator also, it doesn't work. So only way if you can concatenate these iterators is using chain. If you pass the chain, then all the values will be combined. Did you see? Like a sum built-in function with an empty list. So it is doing that. Similarly, if I do like so all the values like a pair if I give and I can give, so it works. So if you give like a list of lists, it doesn't work. Observe carefully. I have two iterators. I created a list of two iterators and passed that. If you pass a list of iterators, it also works like a list of iterators only. But if you do like a star, this is like what spread operator, right? Spread, then it will work. Similarly, itertools dot from iterables means it will go to each of them and do it. So means if you pass like individual list of iterables also, it can work. Now the next thing is about uh, zip longest. Zip longest means like till now we know what zip built-in function, right? Zip built-in function, if you have two iterables, it will pair them based on the position. But if something is greater than that, whichever is the minimum, it will give that much length, right? So in this case, you have 3 values in one and some 6 values in another. But in the pairs, you get only 3 pairs because that much only you have. Next, you have itertools dot zip longest of a1 comma a2. So means like the same thing if you do here, did you observe the difference? In a zip, whichever is minimum, you got it. In a itertools.zip longest, you get maximum values. So you have 6 values, you get like 6 pairs. So whichever is not having the value, it will be replaced by a none. Similarly, in the zip longest, if you don't want the default value to be none, you can write like the fill value. So whichever is having not having values, you can use it. So this zip longest, I generally use not only with iterables. Generally, when I want to combine like this also, with if I want to retain everything, I use this one. Next, there are two other strange things called as drop while, and next I will tell one more. So, okay, till now we have seen iter tools. So all these things are good. This is something very interesting. It filters the sequence items until a condition becomes false. What is this logic? Let me tell you. If I generate a range of values, if I print them, you get all the values. But if I pass like a list of filter of, so some condition, what is this condition saying? X should be greater than 2. Means among these values, if you want values greater than 2 onwards. So then what happens? Generally, whenever you apply this, you get this is the condition, right? Means among all these values, whichever is greater than 2, only those you will get. Means this condition is applied on each of the value. Filtering is happening on each of the value and you are getting final result. But coming to the drop while, it is slightly different. You give like x stated x greater than 2 and you give the evens. What is the even? Which is a list range of values. As you did like a drop while, for the first time it is doing all the values. Generally, you have all these as the events, right? But you get like all the values. You may think like, so sir, why 0 is coming? Why 2 is coming? Am I right? So in the first case, you have values, you did a filter, you got only the values which are greater than 2. But in this case, you have condition as greater than 2, but why you got like 0, 1, 2, so and so? Means it will give all the values of that iterable until unless the first filter condition is failed. In this case, the first case itself, it is failing, right? So filter, then it will give all the remaining values directly. Sir, will anyone will be using this kind of use case? Yes, there could be. I never use it personally, but if there is a condition, you can use it. So if I say x less than 2, so initially it is starting. Is 3 less than 2, 5? Yes. So next, is 12 less than 5? No. So that's the reason from 12 onwards, you get all the values. So did you understand what I'm trying to say? So till this condition is not met, it will not give. Now in this case, you observe x should be less than 5. Is 3 less than 5? Yes. Don't give it. So 2 less than 5? Yes. Ignore this also. Next, is 7 less than 5? No. From there onwards, give everything. Even 1 is less than 5. So minus 5 less than 5, but still it will come. Means till the condition is, filter condition is so satisfied, it will ignore everything, drop. So once the condition is failed, from there onwards, everything will come. This is a strange case of drop while. Now the reverse of it is called as take while. Take while means filter sequence items until a condition becomes true. So in this case here, I told x should be less than 5. So is 3 less than 5? Yes. Then, so give that much only. So is 12 less than 5? No. From there onwards, it will not give all the values. It will break. So if you see, observe slightly. Is 3 less than 5? Yes. Then give. Is 2 less than 5? Then give. Is 4 less than 5? Yes, give it. Is 1 less than 5? Yes. Is 5 less than 5? No. So give all the values till the first condition is break. That is called as a take while. So now we understood the difference between break while and take while. So, so this is one of the interesting thing. If I combine this, so drop while result and take while result for events, and if I chain them, it will be same as a list of values. That's a point. So fine. So the next point is about the star map. So like that for every iterable, they made like some kind of optimization. If I say power of 2, 5, I get 2 to the power of 5. But if I do like a map built-in function with a power, and if I give a list of iterables, then what it says? Hey, exponents missing the argument expression. So it will not work directly if you use as a built-in function. So map, generally we cannot apply like this. But if I do like a star map, if you pass like 2 values, it will do like this: 2 to the power of 5, 3 to the power of 2, 4 to the power of 3. So all those values you are getting. Next, similarly, same like power built-in function, you have operator dot mul, means multiply everything, right? So this is a power operation, exponential. This is a multiplication. 2 5 is a 10. So 3 2 is a 6. 4 3 is a 12. So fine. Similarly, operator dot mul, it will work only for 2 values. If you give 3 values, it will not work. So like that, star map is used for mapping a same like a map on an ordinary iterables. Star map is for iterators. Similarly, product is there. So generally, have you ever done this kind of condition? So looping on the first list, go to the second list and loop over it, go to the third list and loop. Means if you have 3 lists, if you want to get all kinds of combinations, you need to give this much loops, right? So means instead of that, if you do like itertools.product, you get the same result. So instead of you writing this much complex logic, you make the things easy. In fact, I am not passing iterators, I am passing ordinary lists only. So it works. Similarly, so like first take like drop while, take while, like false filter is another thing. it will print only the values that return false for the passed function. If you give any function, for that, what are giving the false? It is a boolean none, 0, right? Whichever is boolean 0, it will give that only. Positive or negative, it is boolean true. So that's why we don't get. If I give like a x greater than 0, so you get only that. So x greater than 0. Greater than 0 means what? So is greater than 0? No. Means false filter. It is reverse of a filter. So what are the filter is happening? It will do the reverse. Similarly, t function is there. So it will return the iterables, those much members. If you say I have a list of values, if I say itertools dot t of colors, I got like two things. So alpha colors and like beta colors, like that I got two. You see here. So if I say alpha colors, I got the red, orange, yellow, so and so. Same values, right? Red, orange, yellow, green, blue. Similarly, if I say beta colors also, red, orange, yellow, color, blue. Means what? Means if you have one iterable, from that iterable, if you want to create those many number of copies, save copies, you did a lot of struggle with using copy module dot deep copy and others. Instead of issue itertools.t, it will generate those many independent things. So if I say itertools.t of a color, it will throw an error. Means by default, it will generate one pair. If you want like 6, you should explicitly say 6. Then it will generate 6 values. So this is all about the itertools functionality. Hope you enjoyed it. So this is a big thing. I know it's a struggle, but it's very interesting. So whenever you are working with large data sets, it's very much paramount useful. So the last thing that we work is about generators. In the generators, same like here, I told why we need generators for optimizing the basic data types we have. So iterables for like functions to optimize, we have generators. So in functions, how to work with these generators means. So till now, you know the concept of how the range works. Range means what? It will take the values from us and it will generate that much. Say range, I told how it works. If you are generating 0 to 1 crore, sorry, with a range of 2, instead of generating all the values, it will store the state that I need to give this one. The moment you go and asking, as it is lazy loading, it will do only when needed and it will give 0. Next, it will change the state that I need to give the values from 2 to this much. So it will give. Next, it will store the state. Means every time only one will be executed. So for doing this, there is another keyword that you will learn now called as yield. Yield is a keyword which will help you in this particular process. If yield is placed within the function definition, it becomes a generator. So what is this logic doing? What it does, let me tell you. Very interesting. So let me take a small function. Let's execute this. You will learn in this way only. Here. Okay. I have a function called as print. I am a function. Now, if I'm making a call to this function, so if I call something as a generator, it will not become a generator by default until unless you make a call. If I make a call, then it will print it. It is saying like I am in the function. Okay, so fine. So what is the point of making it a generator? I will tell you. So in a function till now you have some kind of values. If I say like, return something, return 111. Then what happens if I execute also? It will return. So instead of a return, so if I place it with a yield, I make the same function call again, I will not get anything. So what's the magic? Let's see. So now let's assign this result to something and see the same thing. Let me comment this and do repeat it. First, I will return. Now, if I'm assigning something to it, then what will happen? It is a result which is an integer, which is 111. This is fine. So now I replace it with a yield. Yield is another keyword like a return. But the point is every function will have a return. But not every function will have a yield. The moment you place a yield within a function, it becomes a generator. This is one point you need to remember. See, as I place a yield, the moment I placed a yield, it became a generator. So then who will execute this function, sir? It will not execute. Because it's an optimized or lazy loading object, if you want to get the value, you need to pass the next built-in function. If I give like a next built-in function, I can extract one value from the result. See, I made a call, result I'm assigning to some variable. For that result, I need to pass like next built-in function or for loop. If I execute, I am getting one value now. Now further, if I go and ask one more value, so generally, should I get one more value? It should get generally, but it will throw a stop iteration exception. Because after this yield, there is no value to give. That way it will break the code. Now, what if I write like one more yield statement? If I write like one more yield statement, then did you see now what will happen? First time when you are yielding, you get one value. Second time when you're yielding, you get like one more value. So like that every time. So every time, say like if I do like a /n, you observe what will happen. Each time when you are yielding, you are getting a value, right? So that is how it is working. Now, going further, if I ask for one more value, will you get it? Let me try again. If I am asking for one more value, it will throw again. Because how many yields you have, those many next only you need to call. If you do for loop, it knows how to handle it. But in other case, we need to give explicitly. Sir, what if I'm giving like a hell lot of things, a lot of things? This entire function I want to replace. You see now, I give 1, 2, 3, 4 yields. So when I make a call, I should make those many number of things. So correspondingly. So if I make like a 4 calls right now, if I make a 4 calls, it will work perfectly. 4 calls were working. But beyond that, if I ask, hey, next of this result if I ask, it will throw an error. See? So how to handle that? I told you when you work with iterators. So we need to have something called a stop iteration exception. We need to use that to get the values I told. If I do like stop iteration exception, I will get it. And observe when you're doing a stop iteration exception in iterators, so you will not get any exception message. But in generators, how you are getting message? Because whichever is the return, you will get it. Generally, in a generators, many people don't write returns. If you don't write return, you don't get the exception message. But if you write a return, what are the return message is there? That will go as a exception message. But exception type is every time stop iteration exception only. Then, if I do try to for loop on it, so same like I told about the disposable object, once you get the values like this each time, if you do like a for loop also, you don't get anything. So if you want to again get what to do, should I define the function again or generator again? No. So this is called as a generator calling, right? Like a function call. This object we need to create again. Means if you want to get the values again, so we need to get this object created again. I'm saying like my generator again, and I can go to each of the values. I did like my generator, I'm going to each of the values. Now, if I ask each time any value, every time I want to get the values, I need to again recreate. So reinitialize the generator and get the values. Reinitialize and get the values. Did you see? I did the same logic of others, how we did till now. So this is all about the generators or like a functions, but they were like a optimized functions for helping us. The last point to touch base is about the generators functions. So I think like I told briefly about the generators, how they work. But one thing I want to touch base is either we can use the next built-in function or underscore underscore next attribute. And also I told about the stop iteration exception. The logic is same. The same thing I did with a different example, just to show you the different examples. And yeah, this is one of the good interview question. So you may get whenever you are working with the infinite sequence generation. Assume that like I want to generate n number of values. So how to generate that? Let me see. Yeah. If I have like an infinite sequence which I need to create, generally you can create any values in two ways. In an iterative approach or like recursive approach, are the two things we know till now. I already discussed about Fibonacci series, how to generate the values. Fibonacci series means first two values are 0 and 1, and subsequently every value is a combination of previous two. So we did a logic how to do that, and I told you how to do. So in a for loop, I told that we loop over each other value and do it. So here the beauty is like, so the next two values means tuple unpacking. So we are doing. So the same thing we can do in a recursive way also. I showed you. Using generators also we can do. So means wherever you can do in an iterative approach, that we can replace with a generator. So it will help us. So instead of doing all at one shot, observe carefully what I'm doing. Instead of returning a list of values finally, I'm taking a list and making all the list and pasting all the last. But I'm doing like a generators. Means each time whichever is the value generated till that time it will give. So in this way, if you do, it will occupy less memory comparatively. So when you go for next, I will show something called as memory profiler, called as C profiler. Then you will understand how much memory each is occupying and how much time it is taking. So generally, this is not suitable for small functionalities. Let's say you have like 10 values, 100 values. This is not a good idea. If you have like 1,000 or more, so some big values, then it is very much useful. And the logic is same in terms of implementation, everything. See, this is another way of implementing the same Fibonacci series. But do you see, I did like a yield of this value. Means whichever is the value you are generating for the time you are giving it. So this is all about the basic generators I told. So the next thing that I want to touch base is about a new thing called as yield from, which came recently, I think around 3.7, I guess it came. So the point is like, they found that there is a common pattern we are doing. Say, just imagine, the most common thing people do is like number generator. Means like you loop over some variable, so range, right? Range of n. It will generate those many values. You yield that. So you get a result. So whenever you have this kind of thing, or similarly, if you go in this example, I have a list. I loop over each of the list and get the value. So in both the cases, you did one explicit for loop just to loop over that variable and yield the values. Whenever you have these kind of cases, you can replace it with a yield from that object. I repeat again, whenever you have one iterable and we need to explicitly do for loop to get one value at a time, instead of you doing that, you write like yield from that. It is same as that, but just like with a less logic. So that's a simple thing. And similarly, so the point is like in future, you will learn about the ETL pipelines and others. So like that, we have generator pipelines also. So what do you mean by generator pipelines? Generators means like each one is doing some logic, right? Typically like a for loop only, sorry, like a function only. But instead of doing all at one shot, it will do cumulatively. So this one example, you will learn completely about it. Say, let's say I have a given numbers. I have a given numbers. For those numbers, I need to first filter even numbers within that and then multiply by 3. Then I need to convert to strings. Assume this is the steps. Assume that I was given 100 numbers. If I filter even numbers, I get 50 numbers. Within that 50 numbers, I multiply by 3. So for each of the number, I get it. Finally, convert to strings. Good. For 50 numbers, for 100, you get 50. What if I give 1 crore? You will get like at least 50 lakhs, right? So those many values you need to store. That is a general approach. See here, you take like an even list, you loop over each of them. What are the filtered value you take to a list? Because every time you cannot get out of the list function, right? You generate, and finally, what are the values you got, you give it. This is a general suitable when you have small values. But when you have more, this is not a good way. In those cases, you need to go for this pipelining. So pipelining is very interesting. So how it actually works is, see here, in pipeline, what it does, see in a general case, what happens? You have a even filter, then you have multiply by 3. So each time it's taking numbers and you have a convert to string. Now you see what you do. Generally, which are the numbers you have, it will take those numbers and do all the operation. Let me take this here. Oh, sorry. Okay. Yeah, it works now. So in typical case, what you are doing, you are passing your numbers to this even function. The result will be passed to multiply function. The result will be passed to convert by string. That is how you get the final result. In the same fashion, we wrote the same logic for one more thing, but instead of getting the values, I am doing yield this thing. Sir, why are you not doing a yield from when you're looping over this means? Yield from is suitable when you don't have any other conditions. But here I have some condition, right? And I'm also not giving the value directly. So that's the reason I'm doing. So similarly, if I go here, I'm saying yield from yield, so multiplying to 3. So here also yield the number. Now the point is, the problem can be solved very simply. Same like the above problem. So you combine all of them, but touch me. So it will not generate all values at one shot. So it will generate one value each time. So means like, assume see here, you have these 10 values. So the first among you give 10 values, all the values you give, but the first value will go to this function. The result will go to this function. The result will go to this function. So like that, one value will be processed at a time. So when you go for these yields, so this is called as like a generator pipelining. This is called a generator pipelining. So similarly, you can have like I told about generators all the way, different kinds of things.